Have you ever wished you could travel to the other side of the galaxy in an instant? It's a daydream that many of us have had, but until recently, it seemed like a far-fetched fantasy that could only exist in science fiction. However, recent breakthroughs in space propulsion technology have brought us closer to the possibility of super-fast space travel. Scientists are developing new devices that could unlock the secrets of the universe and take us to places we've never been before. One of these technologies is known as the warp drive, which could potentially propel spacecraft faster than the speed of light. It's an exciting concept that has captured the imagination of scientists and enthusiasts alike, and it's worth learning more about the science behind it. So let's dive in and explore the possibilities of this groundbreaking technology. The idea of traveling from Earth to Mars in just 4 minutes has been a dream of space enthusiasts for a long time. Unfortunately, the distance between the two planets takes nearly 7 months to cover, making this dream seem impossible. However, visionaries such as Elon Musk and Jeff Bezos, along with other accomplished scientists, have started developing plans to make this dream a reality. What exactly are these experts hoping to achieve? The missing piece of the puzzle has always been achieving a velocity similar to the speed of light. To put this into perspective, the fastest spacecraft ever created has a maximum speed of 163 kilometers per second, which is impressive, but nowhere near the speed of light, which is nearly 300,000 kilometers per second. This limitation has made interstellar travel seem almost impossible, as even the nearest star to our planet is located 4.2 light years away. This means that even if a spacecraft could travel at the speed of light, it would take 4 years to reach that star. Before we dive deeper into the concept of faster travel, let's define what is meant by a speed faster than the speed of light. See, light is one of the fastest traveling energy mediums known to humankind and travels in the form of waves and particles. It travels so quickly that we barely notice the time between turning on a light switch and the light illuminating the entire room. This is why in the 1900s, Albert Einstein decided to make light a quantitative measuring unit. He realized that the speed of light stands as the only constant for speed, instead of being a relative force. In later years, he also introduced the mind-boggling notion of time dilation, which suggests that time is simply an illusion that varies depending on who is observing it. In fact, he believed that time could even come to a complete standstill for an object traveling at the speed of light. This meant that if an object moves at the speed of light, it can even defy the concept of time. The concept of light years originated from physicist Friedrich Bessel's theory, which defines it as the distance that light can travel in 1 year. And that distance is incredibly long. Light is known for its remarkable speed of over 186,000 miles per second, which means that you could travel around the Earth's equator about 7.5 times in just 1 second, if you could ride on a beam of light. What if we could develop a propulsion system that's even faster? In recent years, there have been significant advancements in space travel technology, which have drastically reduced the time it takes to travel from Earth to Mars. What used to take 4 years can now be done in just 7 months, and some experts even predict travel times as low as 45 minutes in the future. However, claims of a 4-minute interstellar trip should be taken with a grain of salt. But what about the warp drive? Astrophysicist Neil deGrasse Tyson has challenged SpaceX to work on this technology, which Elon Musk is particularly interested in given his enthusiasm for sending humans to Mars. So what exactly is a warp drive, and why is it so exciting? Let's start with the basics. In 1905, Einstein's theory of general relativity revolutionized our understanding of space and time. According to this theory, space and time are intertwined like a giant fabric. Massive objects like stars, Planets and black holes warp this fabric, creating dips and curves like a heavy ball on a trampoline. Objects in space move along this fabric, following the curves created by these massive objects. The stronger the gravity of an object, the bigger the warp it creates, resulting in a stronger pull on other objects. In essence, space-time fabric describes how space and time are connected and influenced by massive objects in the universe. So what does all this have to do with the warp drive? Well, the warp drive is a hypothetical technology that involves pulling the fabric of space-time while pushing the drive forward. Sound confusing? Well, let us explain further. A warp drive can be thought of as a powerful engine for spaceships that allows them to travel faster than the speed of light. While it's typically impossible for anything to exceed this limit, a warp drive can create a bubble that envelops the spacecraft in space-time fabric, enabling it to travel more quickly. It's as though the ship is taking a shortcut through space, much like folding a piece of paper to bring two distant points closer together. The concept of a warp drive has been featured in science fiction movies for decades, but physicists began exploring practical designs and calculations for the drive in the 1990s. In 1994, Mexican researcher Miguel Alcubierre proposed a plausible calculation for the drive, becoming the first to demonstrate how the propulsion would violate some of Albert Einstein's laws. However, Alcubierre's solution required an enormous amount of energy to manipulate space-time without massive reactors on the spacecraft, making it impractical. Despite the extensive calculations, the combination of this required energy and a lightweight reactor would make it nearly impossible for his spacecraft to leave Earth's atmosphere. Despite the challenges facing the development of a warp drive, researchers have continued to make progress in the field. After physicist Miguel Alcubierre proposed a calculation for the drive, which required an immense amount of energy that was not yet feasible, in 2010, U.S. researcher Dr. Harold G. Sonny White developed a propulsion system that required only negative or exotic energy, eliminating the need for fuel or other generators. The only catch was that the existence of negative matter was still in question. Thankfully, White's problem was solved in 2021 when he was able to provide evidence of the existence of a small amount of negative matter in the Casimir effect. While this is a significant step forward, it's still not enough to power a spacecraft weighing several tons. Yet, this technology holds promise for the future and may lead to a successful launch one day. Introducing the EM microwave drive, a new type of propulsion system. Before the discovery and confirmation of negative matter and energy, researchers were exploring models for hyper-fast spacecraft that don't require traditional fuel sources. One of the most promising concepts was developed by Roger Scheuer, a British scientist and project manager for the Astrium Space Company. His drive operates by trapping microwaves in a copper alloy cone, which then bounce around to create thrust. The EM drive is based on Newton's second law, which states that force is the rate of change of momentum. Electromagnetic waves propagate at an equal speed and generate a certain amount of momentum. This momentum can be transferred to a reflector, resulting in a small amount of force. When accumulated, this force can be significant enough to power an EM drive, without any need for propellant. Although the EM drive cannot travel at the speed of light, it can still make a significant difference in interstellar travel by speeding up the journey. NASA has already announced the successful testing of spacecraft using EM technology, with many successful tests completed. Following this, a group of Chinese scientists also reported a successful test of an EM technology-powered engine. However, doubts have been raised by a German physicist regarding the initiation, propagation, and consistent extraction of momentum from these waves. Further testing and consideration of various factors have brought the feasibility of the idea into question. NASA has been warned that their test series could encounter issues, and they are unsatisfied with the current results. Neither NASA nor the Chinese agencies have commented on the EM drive's failure, leaving hopes for a 4-minute interstellar journey from Earth to Mars back to the warp drive. The future of space travel is filled with endless possibilities, and the potential for warp drive technology could change the way we explore the vast expanse of the universe. Individuals like Elon Musk inspire us with their visionary ideas to make life multi-planetary, such as the dream of colonizing Mars. With ongoing innovation and exploration, there's no telling what amazing advancements await us in space. Regardless of the destination, the journey is sure to be an amazing ride.